Hello, welcome to the channel. So what exactly the vector database is? So before any system we are trying to build, right? So we need to understand like what is the storage, where exactly we store the data, okay, whatever the thing and we are trying to build or the product we are building. So we need to understand like where we are trying to store those, things in the backend, right? So in that case, we need to understand first what is the storage we are going to use for any RAG system or any generative AI system. So like other systems, any other systems, unlike any other systems, we are using, using SQL databases, Oracle database or MySQL database, other things. But for generative AI itself, we are, there are special kind of database being used that's called vector databases, right? Why the vector database is more important, right? So because the mechanism being used for the LLM and understanding the data input prompt or input query and generating the response accordingly, so it need a different kind of storage where it can store the data in three dimensional way, right? If you think of any other database, those databases stores the data as in two-dimensional array, right? Like one is the column, another in the row, right? So here for vector database, it's a three-dimensional, right? So vector database is very, very, very essential for any generative AI system, right? Literally LLM system, right? If you build any kind of LLM application or any LLM product or any generative AI product, so vector database is essential. There are many flavor of vector databases. However, you can use any one you want as for your requirement and as for your need and as for your cost and the use case, right? So more specifically, vector databases. More specifically, vector databases came in handy in building a RAG applications, right? Which is a technique that combines the strength of large language model that's called LLMs with external knowledge sources, right? As we already saw, already learn about those things or discuss a little bit, like for every LLM, we need a massive amount of data where it's trained on, right? And then it can run on top of that any query, right? So that's where we're trying to understand those things. So while we are understanding the LLM, whole RAG workflow, then the essential part is the vector database, right? So that's where we are trying to understand what exactly that vector database, right? But we are not going through the very deep into the vector database, but I'll just touch upon like what are the vector database. How the vector database is responsible to build a generative AI or RAG system. Okay, so the objective of this particular course is ideally, help you to implement these RAG systems from scratch using framework like Quadrant or Llama Index and Olama. The Olama is the framework where by using that you can able to develop any generative AI system or LLM application on your local, right? So yeah, of course, if you don't know any of these frameworks, you shouldn't be worried about that, since that is what we intend to cover today with the proper context, like you understood, right? So this particular comprehensive master class, or we can say the RAG system bootcamp, okay, course will go into a little bit deeper into the RAG by understanding its necessity and elements, and then cover some hands-on approach to building our own RAG system, right? So which will give more insights and practical way of dealing with the RAG system and building the RAG from scratch. Okay, so by end of this particular class, so we'll have a solid understanding of RAG and how to use it in our our own applications. Okay. So let's start. Okay. So while we are talking about the vector database, right? So vector database is, simply put, a vector database stored on structured data. You can say text, images, audio, or video in a form of vector embeddings, right? So here, if you see, we have different kind of, uh, documents available. It's a JPG document, Word documents, MP3 files, video files, all those are available. So while we are storing this, the database, so we are not storing as a blob, right? If you recall that data storage or actual normal, databases, so we can able to store your files as well into the database, right? So how you are going to store those files in normal databases is like a object or blob or cloud, right? But here to store this, data, we have to store as an information, not the actual data, right? So here, what exactly we are trying to do is we are going to store those things into the vector database. But before storing that, we have to convert it to a format where that can be stored in a three-dimensional, space. As I said, that in embeddings in vector database, the data being stored in a three-dimensional space, right? So that's why we have to embed the input data and store into the vector database, right? So that's how it has to be. Okay. So each data point ideally, right, whether a Word document or an image or any other entity, it is transformed into a numerical vector. So using ML techniques, which is you can call as embedding, data embedding or document embedding or whatever it may be. So, right. So this actually this numerical vector is called an embedding, right? Whatever the technique we are trying to convert convert any input data or input document into a vector format, that's numerical vector format. That's called the process is called the embedding, right? And the model is trained in such a way that these vectors capture the essential features and characteristics of the underlying data, right? So if you think of like this particular image, so it's looks like that, like when you are embedding the data, so it's the data getting embedded something in this particular format, right? If you see this numbers, some decimals, so we'll talk about what exactly these numbers, why these are the in decimal formats, and why the array of decimal numbers, right? So those are the things. Like and considering word embeddings, for instance, we may discover that in the embedding space, the embedding of fruit are found close to each other, which cities from another cluster, and so on. What does it mean? So here, where we are trying to understand is like, for example, here is the set of documents we have, okay, and we have given this complete, library of documents, you can say, or a bunch of documents you send as an input to the LLM, and the LLM got trained on top of on these particular documents. Now, if you're trying to ask something, okay, what is the election result were declared on 2nd February? What happened? Right? Well, so LLM will tell, I don't have any idea. Why? Because all this data, all this information provided to the LLM, prior to that, or the LLM train on the document, there is no information related to election or 2nd February available in this. That means LLM is only bound to answer from this set of documents, okay, not out of that, right? So that's why it's saying, I have no idea, right? So in this case, what exactly? So it will maybe try to ask like, okay, tell me my sales in the last year or last quarter or whatever it may be. It might say, tell, okay, I don't have any idea also, right? Because if that is not there, those information are not available in the system itself. I mean, the documents itself will train on. Well, it cannot answer those things, right? So those are the things, ideally happens, right? So how the training system works, right? So we have the huge, or text data set or the documents, or it can be any kind of document, okay? So, and it getting trained through the LLM. The LLM now understands what are the things I need to, so it's kind of, think of like you are, uh, in a standard, okay, 10th standard, for example, right? In your high school or 10th standard. So whatever your subject in your curriculum you have, your brain can only understand those, right? And if whenever you're going to, attempt the exam, in that exam, what will happen ideally, right? Whatever you learn from your textbook, right, or practical, those things you can only answer. Otherwise, if anything questions, you don't know, you might think, okay, the question is out of syllabus, right? It's kind of that. It's exactly same thing happen. Just think of like LLM is one of the brain. We are trying to feed something, some subject to that particular brain, right? Now we are trying to ask some question around that, right? This is how it exactly happens is. Then if LLM doesn't know, so if you are in, maybe you are in grade 10 and someone is asking for a grade 12 question, you cannot answer that, right? Of course you cannot answer that because you don't know about that subject, and you never came across that particular subject or that particular topic, right? Then you cannot answer about that. So that's what exactly the LLM learning model happens and training happens, right? So now once that's getting got trained, now the brain is trained. Brain understands and read all the books or all the documents, whatever, in all the practical way. Now it's time to ask question. So now the brain is going to the exam, and the exemption paper, just think of like you are trying to ask some question to your mind. Okay, what is this? So automatically your brain will answer according to that. Okay, or else if you are asking something out of that, then probably, or maybe you are asking something not specific to one topic or specific to one subject. Okay, so it might go beyond generating a lot of information which is not able to respond you back, right? So in that case it will say like this is too much information, coming in the prompt. So it's the kind of that, right? So now how this prompt, the vector database really solve this problem, right? If you think of like, prompt, right? So first prompt is tell me my sales in the last 10 days. Then how this guy getting stored into the database? So what it will try to do is, like, before that we have already stored the details into the vector database. Those are on scene, right, into the database. Like how we have stored all these things in a different different format, in the sense like in a 3D space, right, with with area of numbers, numerical numbers representation. So now if you are asking some question, first the question getting converted into the vector format, right? Then that vector format getting will be searched inside the vector DB, and it's trying to get the answer out of that particular database, right? And again convert back to the normal text, and it will respond back to the user because you are asking the question, right? So that's what it will happen. Then if you see here, the prompt getting encoded ideally. So this is encoded to a specific format, and it will try to fetch the neighbor in the sense like which what are the numerical arrays available in the storage. Those are very near to this particular number, this particular array of numbers, right? So those are the things it will try to fetch and try to get the answer out of that, right? So in this case, how it look like when from one end to other end, how the data getting stored and getting, fetched, right? So here when you think of like, you are trying to store some of the information into the vector space, right? How you are storing. Whenever you're storing, eh, well, here, if you see this example, right? So whenever you are trying to store one chicken, right? The word called chicken, you are storing that word getting stored as a chicken at this point of time here, right? Correct. And when it's coming as a wolf, so it's kind of, in the category of animal. So in animal category, so all these things are stored in very nearby, right? In the nearby. So it can be also make cluster like when wolf is not a, pet. Maybe if it comes to a pet, then the, set of pet information will be clustered in one place and other place in the animal and other things, right? It's kind of that. It will try to store the data information such a way like all those information are related and they will be stored in very closer to each other as much as possible. So that whenever it will try to search, it will easily try to search in that vector space, right? And likewise, while you are storing the information related to the banana, right? And you're storing the information related to the apple, right? And orange. So this kind of thing. So whenever you're storing those things, all these are fruit comes in the fruit category, right? And it goes to the fruit category itself, right? And it makes a cluster very much nearby the place, right? So now what it will happen? So now here also there is another thing. Okay, here Google and Apple, how it will try to differentiate between apple and apple, right? This fruit apple and the apple company, right? So this is another some more information required to store those things to make it relative, right? So now if you see whenever you're storing any information in the vector space, every vector space has a address, right? You can say this is address, like memory space address. It has a set of numerical, it's a array of numerical values, right? So accordingly, it stores the information and identifies, okay, where should the new information to be stored, and it will find out the nearest number for these numbers available in this array and try to find where to store, right? If next time I'm trying to store orange, then it should find the orange, it will have its own numbers when it will be converted, right? And that number will be matched with these numbers where exactly the nearest number available. So it will find the nearest numbers will be somewhere around banana uh, or apple, right? And then store somewhere here nearby. Okay, maybe this number, this point or this point, wherever somewhere it will try to store here because it will try to create a uh, cluster of fruits, right? So here, while you are searching, let's search. When you are searching this, what will happen? So we are trying to search what? The chicken, right? So when it's trying to search it, so it will try to query the kitchen, right? So the kitchen, while it's trying to query a kitchen, so kitchen is comes, comes around and it's very relatable to pet, right? So wherever it will try to store, first it will go to the while searching, first it will go to the animal set of cluster, right? From the animal set of cluster, what it will try to do is it will try to find where the pet cluster are available. Maybe this is the cluster for pets, right? So it will try to make a it will might try to search from that particular that particular area, right? And it try to find the kitchen from there. Okay, so it will try to match with this kind of numbers, and try to find the place where exactly it's available, right? So now, if we think of like how, how the vector, the vector database works behind the scene. So whenever we talk about this, right? So the first and foremost is like it will it will get here is the user ask any question. Okay, so user ask any question goes, it converts into the numerical format. once it converted into numerical format, it will try to embed into the data store, vector store, right? So it will store here. So now the next time when it will try to do, it will try to identify or source this particular number nearest related numerical numbers or arrays, and then it will find out and then convert into the related text out of that. Then it will try to store it, respond to the user as a response, right? So this is the question, and this is try to make a context out of that and try to respond to the user, right? So this is how the flow works, right? Okay. So if when we think about this one, how what exactly the how the embedding and vector store comes in action. So ideally, so any structured or unstructured data comes as an input, okay, and those data, input data or documents or whatever it may be, first translate into the vector database, right? The vector store, different kind of, not till now we didn't store, it's just converted into the vector type, right? And then embedding, right? So each vector set of vectors will be create the embed out of that particular vector and will be stored into the vector database. Now this comes the other way around, right? So now query will be performed by any user. So any user, what user try to do, okay, explain about some image. The user will upload one image and say like, okay, tell me about this image. Now that image also will be first converted into vector, right? From vector to converted into embed, right? So now once the embed, once it convert to embed, now it will try to shoot into the LLM and try to find the nearest neighbor. Nearest neighbor in the sense like whatever the here the embed is generated from the question asked by the user, it will it will be search in the nearest neighbors will be searched from the vector database, okay, and then try to get the result, right? So that result also it will get as a vector format only, right? Then it will convert into the original text format and then send it back to the user as a response, right? It's answer. So user asked the question and it got the answer out of that, right? So now this is what it's looks like, the complete RAG architecture, right? What exactly this looks like. So ideally, if you see, like a RAG is nothing but it's a retrieval, augmented, and generation, right? So what exactly the retrieval means? So retrieval is nothing but accessing and retrieving information from knowledge, the knowledge source, such as database or any memory space, okay? In this case, you can say like, vector database, right? Or any in-memory data available, right? What is augmented? So augmented is nothing but enhancing or enriching something, right? In this case, the text generation process with additional information or context, right? So whenever we are trying to augment the data, augment any information, right? So that information getting pulled from a data store, okay, and try to convert those into a specific format, okay, and try to match it, right? So once it will be matched, and it will try to get the related neighbor data, neighbor information stored in the data store that we already talk about in our previous slide, right? And then what exactly generation is? So generation is nothing but the process of creating or creating or producing something. In this, in this context, what did we be? Generation of text or language or the response, right? So whenever we got this, got here, the uh, uh, the the augmentation, according to the augmentation, the what LLM will try to generate those text out of those augmented data, augmented information, and create a response out of that, and then send it back to the user wherever it's asked for. So it's all about, it revolve around these three concepts, right? So the whole architecture, revolves around. Thank you. Please subscribe and share and comment whatever you can feel like.